Hi, Emmanuel here. Welcome again to another class. Trigonometric identities. Now, some people call this the fundamental trigonometric identity. Some others call it the most important trigonometric identity. How about you? What do you say? Now, in this class, we're going to show why this is equal to 1, and then we're going to go a step further to iterate this to obtain two more identities. Now, let's get into the class and try this out. Welcome again. So, to obtain this identity, we'll have a right angle triangle like this. The vertices, let's say A, B, C. So, we can use this as our reference angle, theta. So, what this means is that this is the side opposite to A. So here will be A, this side opposite to B, here will be B, and this is our C, which is the hypotenuse. So, going by Pythagoras theory, theorem, we'll have A squared plus B squared is equal to C squared. So, if we have this, then we can decide to divide all through by C squared. We divide all through by C squared. But this one will give us 1. Then this will then give us A squared over C squared plus B squared over C squared is equal to 1. And this is equivalent to A over C squared plus B over C squared. Now, look at, if we want to obtain the sine of this angle, sin theta will be equal to opposite over hypotenuse, which is this opposite, which is A, over the hypotenuse, which is C. And then cos theta will be adjacent over hypotenuse, which is the adjacent of this angle, which is B over C. So this thing we have here, which is A, so we have our sin theta, which is A over C, which is this, squared, plus our cos theta, which is B over C squared. Cos theta will equal to 1. Now, remember that if you have sin theta squared, it's not equal to sin theta all squared. What this presupposes is that if you have this is the angle will be squared. So, for example, if this theta is equal to 5, so this will be sin 5 squared, which is sin 25, while this will be sin 5. So if we find the value of sin 5, then we'll square the whole stuff. So this particular scenario is what we have here, and this is denoted like this: sin squared theta plus cos squared theta is equal to 1. Now I know that the placement of this and this is not the same, but it's basically the same thing, because plus this plus this or this plus this is the same thing. So we'll have this. So With this now, we can decide to now iterate this to obtain from two more identities, like I said before. So have we can divide everything by sine squared theta, sine squared theta, then sine squared theta. If you do that, of course, this will give us 1 cos squared theta over sine squared theta. Remember that cos theta over sine theta is the cotangent of theta. That's called theta. So if we square this now, we have cos squared theta. So cos squared theta over sine squared theta will give us, we have 1 plus cot squared theta will give us, this is 1 over sine squared theta is cosec squared theta. Now if we do the same thing again, we have sine squared theta plus cos squared theta is equal to 1. If we divide everything by cos squared theta, and cos squared theta, this will give us 1. Sin theta over cos theta is tan theta. So if we square this, we'll have tan squared theta. So we'll square this now, have tan squared theta plus 1, and this will give us 1 over cos squared theta. This is sec squared theta. So these are the other two identities that we have obtained from this. So have this, and this as our identities. So keep solving problems. Don't worry from them. Until next time. Bye bye.